Now we'll see the today uh, classification of network elements. All right. So the first classification of a network element is active and passive elements we have. All right. So active and passive elements. An element is said to be active if it is able to deliver the energy to outside world for an infinite time. Otherwise, it is called as passive. So an element is said to be active when it delivers the energy. Right. When it delivers the energy, we call it as active element. And when it consumes the energy, otherwise means what? Consuming the energy. When it consumes energy, then it is called as a passive element. So example for active elements are sources, and example for passive elements are R, L, and C. Right. So sources deliver the energy. Sources delivers energy, whereas these passive elements consumes energy, consume. Right. So now Ohm's law is not applicable for active elements. Please make a note that Ohm's law is not applicable to your active elements. If VI ratio, voltage current ratio, V by I ratio is positive, then it is called as a passive element. And passive elements cannot supply more energy than what it had drawn previously. So passive elements uh, cannot supply more energy than what it had drawn previously. See, these are the important points to be noted by as far as the passive and active elements are concerned. Then coming to the second category, so linear, non-linear elements. So linear, when we say linear means straight line and Ardham. So when their characteristics in the sense, if you talk any element characteristics in terms of electrical, always we talk in terms of voltage and current characteristics, VI characteristics. So if VI characteristics of any element is a straight line, then it is called as a linear elements. So the examples are R, L, C, where R is the resistance, L is the inductance, and C is the capacitance. Non-linear elements are diode and transistors that you might have been, you will going to study in EDC also, right? In normal physics, in intermediate, you might have been studied about the diode and transistors, RLC parameters. No, no, so your linear elements, the RLC parameters will comes under the linear element, and whereas your diode and transistor will comes under the non-linear element. Since their VI characteristics are not straight line, then you have another category of uh, um, elements, unilateral and bilateral elements. If an element offers same impedance for both the directions of flow of current, throughout it is called as bilateral element, otherwise it is unilateral element. So you please see that this definition, if an element offers same impedance, so impedance is nothing but the opposition force, right, for both the directions of flow of current, then it is called as a bilateral element. Look at this diagram here. So suppose this is an element, this box is an element, and a current I is allowed to pass from A to B. And the same, and when the current I is allowed to pass from A to B, and it offers a voltage potential difference like this, there will be a potential drop. There will be a potential drop due to this element. And when there is a potential drop, therefore, as per the Ohm's law, you might be knowing it. So V is proportional to I and V is equal to I into Z, where Z is the impedance of the circuit. So which is opposes this one. Now, when the current I is passing through this is offering this impedance. Now in the same circuit, if I allow the current from B to A like this, ఇందాక ఏం చేసాం, we have allowed the current from A to B like this. Now we are allowing the current from B to A in this direction. So when we are allowing the current from B to A, this offers a potential drop in the given polarity like this. Plus here and minus here. ఎందుకు potential drop, when the current flows in this element, there will be a drop in the voltage, and this drop in voltage is represented by the polarity plus here and minus here. ఇక్కడ పొటెన్షియల్ డ్రాప్ వస్తుంది కాబట్టి ఇక్కడ ప్లస్ వస్తుంది, ఇక్కడ మైనస్ వస్తుంది. ఎందుకు? కరెంట్ ఈస్ ఫ్లోయింగ్ ఇన్ దిస్ డైరెక్షన్. సో నౌ విత్ ద సేమ్ వన్, therefore your voltage is equal to I into Z in this case also. And then we say this is the impedance Z. So same impedance it is offering. So now as per the definition of this bilateral element, if an element offer the same impedance for both the directions of current, see here, current, when the current is reversed in here, it is also offering the same impedance. When the current is flowing from A to B, it is offering Z. And when the current flows from B to A, it is also offering the same current Z. So therefore, same impedance Z, therefore it is called as a bilateral element. So this element is called as, so the examples of bilateral element are RLC, resistance, inductance, and capacitance. That is, if you take instead of that this impedance, if you take a resistor here, resistor symbol is like this, and if you pass a current I in this direction, then for potential across this one is VR. And in the same resistance, if you try to pass the current in the reverse direction like this, if same current I, and the potential would be plus and minus with R like this, and it also offers the same resistance. Therefore, that is, this resistor allows the current in either direction like this. Let this point A and this point is B. Therefore, it allows either from A to B or from B to A like this. So this resistor element is called as bilateral element. Similarly, inductor also. Inductor we represent it like this, and the capacitor also we represent it like this. So inductor is represented by inductance and capacitor is represented by capacitance. So therefore, the RLC are bilateral element. Then coming to the unilateral element, the example for unilateral element is diode or transistor. Because if you look at the diode, this is anode and this is cathode. So diode carries current when it is forward biased. ఇది మీరు ఫిజిక్స్ లో చదివే ఉంటారు. సో వెన్ ఇది ఫార్వర్డ్ బయాస్డ్ కండిషన్ అంటారు. When a positive terminal is connected to the anode and a negative terminal of the battery is connected to the cathode, then it is called as forward biased. Right, and under this condition only the current I will try to flow from anode to cathode. Suppose if you reverse this one, battery terminals like this. So if you connect a positive terminal to the cathode and negative terminal to the anode, then no current will flow in this direction because your diode does not allow the current in the reverse biased mode. This is reverse biased. So that you will going to study in EDC, right? So your diode does not allow the current I in this direction. So that is why this is called as unilateral element diode. Similarly, transistor also. Right, that is therefore these are the two examples ఇది ఇక్కడ explain చేసింది. For a forward voltage diode acts as a short circuit, that is R is equal to 0. In reverse bias it acts as an open circuit, that is infinite resistance, your diode. So here diode offers different resistance for different current. Therefore it is called as unilateral element. If VI characteristics are same in all directions, it is called bilateral element. ఇక్కడ print అవ్వలేదు. Right. So this is about the unilateral and bilateral elements, right? Then we have another classification, time variant and time invariant elements. So what is time variant? Time variant, you see here, if the element characteristics are independent of time, it is called time variant, and otherwise it is time invariant. It here wrongly printed it here, it is time invariant. Otherwise it is time variant. So if the element characteristics are independent of time, it is time variant. So now see here these two characteristics here, and case one is if Vi is positive, it is passive element, and bilateral and linear element. See here, voltage V by I is positive. So V by I is positive only in this quadrant. See here characteristics. Why? Because it is positive in this quadrant and in this quadrant also. ఎందుకు రెండు నెగిటివ్ ఉన్నాయి కాబట్టి V by will always be positive in this one, and therefore then that type of element is passive element, bilateral and linear element. Let us take the case 2. V by I ratio is positive in one quadrant and negative in another quadrant direction. It is not both in same both directions. So it is the active element, and unilateral element, non-linear element. So it may be an active element, unilateral element, or non-linear element. Like this. This is, see here, during the first quadrant, V by I is positive. But whereas here it is V by I is negative. ఎందుకు V negative, ఇక్కడ V negative and I positive. Therefore overall V by I will become negative, and this sort of case we call it as, that is during Vi positive one quadrant and is negative in other direction, and in the E quadrant lo, second quadrant lo it is negative, whereas in the first quadrant it is positive, and therefore this sort of characteristics, Vi characteristics ఉండే వాటిని ఏమంటామంటే either active elements or unilateral element అని అంటాం, or non-linear elements అని అంటాం, right? Then you have another characteristics of lumped or distributed elements. So lumped elements are those elements which are very small in size, in which simultaneous actions takes place. Typical lumped elements are capacitors, resistors and inductors. అంటే lumped means what? As a whole అని అర్థం. Lumped means as a whole అని అర్థం. So స్మాల్ ఇన్ సైజ్ ఉంటాయి, వాటిని మనం రెసిస్టార్స్, ఇండక్టార్స్, కెపాసిటర్స్ని లంప్డ్ పారామీటర్స్ కింద ఆర్ లంప్డ్ ఎలిమెంట్స్ కింద చేస్తాం. డిస్ట్రిబ్యూటెడ్ ఎలిమెంట్స్ ఆర్ దోస్ విచ్ ఆర్ నాట్ ఎలక్ట్రికల్లీ సెపరేటబుల్. అవి ఎలక్ట్రికల్గా మనం సెపరేట్ చేయడం ఫర్ అనలిటికల్ పర్పస్. ఫర్ ఎగ్జాంపుల్, యువర్ ట్రాన్స్మిషన్ లైన్ of power systems has distributed parameters along its length and may extend for hundreds of miles. So మన ఎలక్ట్రికల్ సిస్టంలో చూసుకుంటే పవర్ ట్రాన్స్మిషన్ లైన్స్, అవి మనం you might have been observed that power transmission lines are used to transmit the power from generation to the distribution side. All right. Thank you one and all. We'll meet in the next session.